Hello, Mario! In this video, I'm going to take a look at bearings, booking bearings during a survey, both left and right face, meaning them, and producing an unadjusted bearing. So let's get cracking and see how that goes. So first up, your bearing is measured clockwise from north. So here's north here at 0 or 360, and we always go clockwise. We always measure our bearings clockwise from north. And you can see here we've got all these various little directions in here. But the predominant one's north at 0, east at 90, south 180 and west at 270. So they're always measured clockwise from north. That's a pretty simple concept that it pays to remember and keep in mind. Now, if we look at the line A to B, we can see that if we measure an angle clockwise from north, from A to B, of 35 degrees 15, 20, that becomes the bearing. However, if we are at B and we measure a line clockwise from north, which north would be up here, we would be measuring from here all the way around there like that angle there. Now, up here like this. So we would be measuring all the way around there, 180 to there, and then plus this angle here, which would be the same, 35, 15, 20. So we would have to add 180 degrees to it. So the bearing from B to A is 215 degrees, 15, 20. It's just the bearing from A to B with 180 degrees added onto it. And that's sort of called the reverse bearing, or if you were at B, the back bearing to A. And there's a bit of a rule for that. To reverse a bearing, if the bearing is less than 180 degrees, add 180. If the bearing is more than 180 degrees, take away 180. So remember that bearings are measured clockwise from north. So from B to A, north would be up here, and we would be measuring this angle here, which is just quite simply 180 degrees plus this angle here. So let's look at another one. Here we are from C to D. And I can see there that the bearing shown, 327, 26, 30, has been measured from north all the way around to here, 327 degrees, 26, 30. Now the bearing, however, from D to C, we've got north up here, it's measured clockwise, it's not quite as far. What we do there is take 180 degrees off. And as it turns out, 180 degrees off 327, 26, 30 is 147, 26, 30. So quite a simple rule. If the bearing is less than 180 degrees, the reverse is 180. And if the bearing is more than 180, take away 180. So how do you know which way the bearing goes? Well, it's quite easy, because just draw a little line going north and then imagine the angle. So you can quite clearly see that that would be 35. And here you are, you put your little line in north and come right around there. You know that 327's always there, because if we just go back, we know we've always got our little compass. We're always pointing north, so we know where 30 degrees is. We know where 130. It's pretty easy to work it out. So which way the actual bearing is going. So sometimes on plans we might write a bearing from A to B, 35, 15, 20, or just depending how things have turned out or how the plan's been drawn, we might write that same bearing as 215, 15, 20, in which case we know it's the bearing going from B to A, because we know our basic first principle, bearings are measured clockwise from north. All right, so we've got that bearings thing all hopefully sorted there now. Let's just move on. Why measure on both left face and right face? So when we do measure accurate measurements, especially when we're traversing and for control surveys, we measure on both left face and right face of the total station. Why do we do this? Well, it eliminates a number of inaccuracies present in the total station. Now, some of those inaccuracies are just because of the construction. It's very difficult to make an absolutely accurate instrument. So some of the things might not be at right angles to each other. The instruments are very small, and as I've said quite a number of times, that a millimetre at the station is probably going to be 100 millimetres error 100 metres away, or words to that effect. So little small inaccuracies can obviously accumulate and get bigger as we go away. Now, some of these inaccuracies are present in the construction, and some of them are related to the adjustment of the instrument. So some of them can be carefully adjusted out by the surveyor, but I would suggest an instrument technician is the best person to be working with these adjustments. They're a person that does them day in, day out. They know all the little intricacies, and probably, although they cost a little bit of money, will save you time and money in the long run, because they know what they're doing and they are very experienced at it. Now, in the course notes, in the resource section of the course Moodle site, I've put a number of notes and things around this that I would advise you read further, or at least have a skim through and get an idea, because some of them do come up in questions. So there is some resources there for you to look through. In particular, they relate to theodolites. Now, the theodolite is the precursor to the total station. Essentially, all it did was measure angles and angles, horizontal and vertical, and did not have any distance measurement capability. But the left and right face issue is related entirely to the angles, and obviously distances have adjustments and errors of their own that we will look at somewhere else. So the theodolite in its application has a lot of good information around angles and the measurement of them, and various routines and things that you would probably be well to read, as it gives a very good insight into what a professional surveyor would be doing with this sort of thing, and some good routines, good basic simple stuff that would be paid to get into your repertoire. Theodolite adjustments extract from a book, Modern Theodolites and Levels, which was modern, was sort of modern, when I was studying surveying quite a few years ago. It's sort of hasn't quite withstood the test of time. But there are some very good ideas in there, and concepts around theodolite adjustments, and a lot of these adjustments are minimised or certainly got out of the way by doing a left face and a right face and taking the mean. It's very similar to the builder's level. If you wanted to check a builder's level, you put it on a level surface and flip it through, check the bubbles in the middle, and then put it through 180 and ensure that it's still in the middle. It's the same concept that we use with the prism pole, if it's non-verticality, where we do one shot and then we turn the pole through 180 degrees and do another shot and mean them. All of this is taking out issues around, in particular, the verticality of the pole, how good the plumbing is of the instrument, that the various parts of the instrument are at right angles to each other, and all of these things, which are all in the notes there. And by examining and looking at old exam questions, you'll see what the essential elements of this that you need are. So now that brings us to another little issue that comes up with the left and right face, and that is the idea of taking the mean. And I've got an example here, and a completed example here. And I know some of you struggle with this idea of taking the mean of the left and the right face. Remember, we're only really meaning the minutes and seconds, because the degrees will be 180 different. They should all be 180 degrees different to the left face and the right face. So we don't worry about the degrees we use are the ones from the left face, but it's the minutes and seconds. Now I'm just going to move ahead because I've made a couple of little things here just on how to deal with this. So meaning left and right face readings 1. In situations where both values are on the same minute. So if we look at this example here, I've got DDD, which means degrees, degrees, degrees. It could be any number, but a number of degrees. 14 minutes 28 is the left face reading, and 14 minutes 56 is the right face reading. Now both of those readings are on the inside the 14th minute. They're between 14 minutes and 15 minutes. So what we can do there is we can just add the 28 and the 56 together. So we add 28 plus 56, which comes out to be 84, which is slightly more than my age, but not a hell of a lot. Now we then divide that by 2 to take the mean or the average, because we've got 2 readings. We're taking the average, and we get 42 seconds. So that would mean that the mean for that particular one would be 14 minutes and 42 seconds. And that's, as it turns out, is halfway between the face left reading and the face right reading. The difference between the two is obviously halfway is 28 plus 14 to 42, and then 42 plus 14 to 56. So they're 14 seconds either side of the mean, which is what you would expect. So that is in the situation where both values are on the same minute. So now moving down to the situation where the values are on a different minute. So in this case here, in the face left, we've got 38 minutes 23, and on the face right, 39:47. So how do we find the mean from that? Well, let me tell you that we don't add the 23 and 47 because they're on different minutes, and as you can see, they're progressing. Remember that they would be going clockwise, so we want to go halfway between there and there. So what we must do is work out what it is from the 38 up to the 39. So that's 37 seconds. 23 plus 37 equals 60. So that's how far it would be from there up to the 39th minute. And then obviously from the 39th minute to 39 minutes 47 seconds would be 47 seconds. So we know that therefore from between the two, the difference between the two is going to be 37 plus 47, which is good old 84 again. Now, then we go halfway between 84, which is 42. Okay, that's going to be 42. And we know that then the mean must be 42 seconds from 38:23. So we could add 23 plus 42. That gives us 65. Now 65, we know that there's only 60 seconds in a minute, so 65 is obviously going to be 5 seconds past 39. So therefore our mean would be 39:05. Okay, 23, which was where we started, plus the halfway, the 42, gives us 65, and therefore the mean would be 39.05. And just doing a quick check, you can see that 39.05 plus 42 would give you 39.47. And so slightly more complex where we have values that have different minute values, 38, 23 and 39.47. So let's go back now, not to there, but to our examples, and let's have a look at those. So, and then we will also have a discussion around the orientation correction. So, here we are, we've got our two measured left and right face, and we've got 15, 16, 15, 38. They are both on the same minute, so we could add those together and we would get 6 and 8 is 14, 54. Half of 54 is 27. And now with regards to the orientation correction, when we were doing these, we may as well do that while we're here. 163, 15, 20 is the known bearing. It's the known bearing between ITMM and Old Iron Spike and Iron Spike 4. 16, and that's what we were trying to set. Here we were trying to set 163, 15, 20, but we actually got 163, 15, 27. So we have to pull it back every 7 seconds. So everything's got to come back 7 seconds. That's why the orientation correction applies to everything that we measured with this back bearing here. And that gives us 163, 15, 20. Now, this is not the only way that we can do these. Let's not forget that we could do these on the calculator. So I can show you how to do this on the calculator, which would be 163 degrees, 15 minutes, 16 seconds, like so. 15, 16 plus, and then I'd have to make it 163 because we wanted to make it the same. 163 degrees, 15 minutes, 38 seconds equals, and then we would have to divide that by 2. Divide by 2 equals, and there you see we would get the 163, 15, 27. Now that is quite slow, but it can be done. So I'm just going to put the timetable, the calculator away there for now, and let's have a look at the next one. So here we've got 225, 32, 54, and 45, 33, 16. So they're on a different minutes, 32, 54 and 32, 16. So 6 seconds up to 33 and then 16. So 6 plus 16 is 22. Half of 22 is 11 seconds. So that would make it 54 plus 11 would be 33.05. Now the orientation minus 7 seconds, and that's going to make it 225. It's the left face bearing is always the true bearing. 225, 32, 58. Okay, so that's that one done. So we could bring the calculator over and just show you how that works. So you would have to just, you could either stick with 225 or just go with 0 and just work with the degrees a minute. So 0 degrees, 32 minutes, 54 seconds, plus 33, 0 degrees, 33 minutes, 16 seconds, 16 seconds. And when we add those and divide by 2 equals, and there we'd get our 3305. So you can see it can be done on the calculator, you just have to be a bit careful with the minutes. So yeah, and then we subtract our 7 seconds, which we can actually do that on the calculator as well. I'll just bring the calculator over. Yes, we can do that on the calculator as well. So it's just go minus 0 degrees, 0 seconds, seconds equals, and there we get our 3258. So these can be done on the calculator, but it's a bit slow to do it like that, but correct nonetheless. So let's move on to the next one, 285.56. So they're both on a different minutes, 56 and 57. So it's 13 up to 57 plus 3 is 16, half of 16 is 8, 47 plus 8 is 55, minus 07, 285, 56, 48. So with practice you can get these done quite quickly in your head. Peg A, 301, 02, 27 and 120, so they're actually on a different degree either side, 59, 54. So 59, 54, 6 seconds up to the 0, plus the 27 gives 33. Half the 33, and I think I've got this one wrong. Half the 33 is 16, and that should be a 10 in there. So let's see if we can just fix that up there. Yes, so that should be a 10 there, not 16. So let's just go from the current slide. Yes, so that I've made a bit of a mistake there. So it's actually 33 is 16.5. So I've just gone to the nearest second. So 54 plus 16 would be 0010, 301 0010, and of course minus the 7 there is going to have to fix that up as well. Yes, just that's going to be 03 there. So yeah, it's very easy to make mistakes with these. So yeah, perhaps you should use a calculator. From the current slide, so back up to there. So that's how it goes, 3010103. So yep, I'm happy with that. All right, and now for the next one, I've left an easy one for the last one. They're both on the same minutes, so 37 and 3, we can add them together. Half of that's 20, minus 07. Oh, what have I done there? Gone a bit haywire there as well. That should be that should be 13. I've taken the 7 off. So like that there, 07, 13, 16, 13. Okay, so as we can see there, it's very easy to make little small mistakes with these, and these can have quite a significant effects later on. So it's very important that you get quite accurate with them and do them nice and tidily. There. So that's that one filled out. Just one other thing to remember is that depending on where you're going next, so if you're going to at ITMM to Einspike 4, if you're going to Einspike 4, the bearing from ITMM to Einspike 4 is 163.15.20. But when you're at Einspike 4, you would want to use the reverse bearing, which would be 343.15.20. 343.15.20 would be the bearing from Einspike 4 to ITMM. If you're going to iron tube XX, the bearing from ITXX to MM would be a 45 32 58. That's the unadjusted bearing. And similarly, if you're going to BM27, the bearing from BM27 to ITMM would be 105 56 48. So that would be the bearing that you are using. That would be the known bearing that when you got there. That would possibly, in most cases, be the one that you were using as what we call your back bearing, or the starter of the one there, the information that you know. So there you go. That's a little bit of information there around bearings, left and right face, and what have you. Cheers! See you!